Okay, so if we're going to write this as an augmented matrix, it would be 2, 1, and 2 is the constant to go past the vertical bar, and then 5, 3, and 9. Note your homework has systems like this written in a really similar way, but instead of x and y, they have x1 and x2, and this is the same. This is like solving the same thing. So just a note if you see that in your homework. Okay, so the goal is to have 1's on the principal diagonal, so the goal is that this would become 1, 0, 0, 1, and they'll end up with a number here and a number here that comes out from the process. So I want these to be 1's, and I want these ones to be 0's. Generally, you're told to try and get the 1 in the upper left first. So we want to think about, is there something I can multiply by the second equation so that when I add it to the first, it would make that a 1? Or that doesn't seem that easy to do because 5 would have to be multiplied by a fraction to be added to row 1 to make this spot a 1. I don't really want to involve fractions unless I have to, so is there another way? So remember, the things you're allowed to do is you can multiply any row by any constant multiple and add it to another row, or you can just multiply any row itself by a constant multiple, or you can interchange rows if that ever is something that you want. Okay, so let's see. Why don't we multiply row 1 by 1/2? Because that seems like the easiest thing to do to make that a 1 up here. So if I multiply row 1 by 1/2, I can actually replace row 1 with that. So remember, that is one of our things we're allowed to do. You can multiply any row by all the way through is the key, by a constant, and replace that row. It's basically the same thing if you take an equation and you multiply both sides of it by 1/2. As long as you multiply both sides by the same number, it's equivalent, right? So 1/2 times the 2 gives me a 1. 1 times 1/2 is 1/2. 2 times 1/2 is 1. So far we have some good progress. We have a 1 in that upper left spot, which is what we wanted. Okay, what's up next? So remember, you also want a 1 in the bottom right. Down here where that 3 is, you want 0's across the other spaces. Generally, you try to go for a 0 in the left corner next. Okay, so I can think of an easy way to do that. If I multiply the first row by -5, that first element in the upper left corner would be a -5. If I did that when I add it to the 5, would make a 0. So remember, what we said we want to do is we multiply row 1 by -5 and add it to row 2. So remember, whichever you're adding to, I'm adding this to row 2, is where it gets replaced. So you're doing something to row 1 and adding it to row 2, but row 1 isn't changed because you only replace the row that you're adding to. So if I multiply the first row by -5, 1 times -5 is -5. Being added to the 5 is 0. So that came from the 1 up top in the corner times -5. I'm adding that to the space below and I get 0. The next spot, I would be taking the 1/2 and multiplying it by -5. This is a little bit ugly because we've got fractions. Whoops. And then I'm going to add that to the number that's already there, 3. So I've got -5/2 plus 3. -5/2 is just -2.5, so -2.5 plus 3 is 1/2. So this is 1/2. And then I still need to do all of this for where that last position is. So this is getting a little cluttered. But this number in the last spot comes from taking the 1 at the top, multiplying it by -5, and adding it to that last spot in the bottom. So -5 plus 9 is 4, so this is a 4. So my matrix, to write it a little bit prettier, is at this stage. Okay, so remember where we're heading. We're trying to get 1's here, so that 1/2 here is going to have to become a 1, and I need 0's in these spots. I got half of that done. So step 3 is generally to try and get a 1 here. So the quickest way is I'm noticing, well, hey, if I multiply row 2 by the number 2, that would become a 1. So I can do that. Now there's many ways to get the answer, so you don't have to take the same route as me or in the same order, and you'll still get the same answer in the end. So 2 times row 2 can replace row 2. So I'm not doing anything to row 1, but row 2 I'm multiplying it by 2, so 0 times 2 is 0, 1/2 times 2 is 1, and 4 times 2 is 8. I'm almost done. Of course, I'm running out of room, so I think I will delete some of these notes on the side. Okay, so the only thing left to do is for this spot to become 0. How can I do that? Well, one way, and of course there's more than one way, is if I multiply row 2 by -1/2, because -1/2 here plus that spot up top would add to be 0. So I'm multiplying the bottom by -1/2, adding it to row 1, so the one you add it to is the one that gets replaced. So I don't want to touch that second one because I'm just replacing row 1. -1/2 times row 2. 0 times -1/2 is 0. 0 plus the 1 stays 1. 1 times -1/2 is -1/2. -1/2 plus 1/2 is 0. 8 times -1/2 is -4. -4 plus 1 is -3. My matrix is in the form I wanted, so now I have my solutions. X is equal to, let me get another color. So X is equal to -3 and Y is equal to 8, and that's my answer. I'm mentioning a lot of rules, so you would hopefully have just looked at those before you start this. Remember that any two rows can be interchanged. A row can be multiplied by a non-zero constant. I did that at some point, right? I did like 1/2 row 2 and replaced row 2. So I use that second thing for sure. The third, I definitely use that too. A constant multiple of one row can be added to another row. So you can multiply a row by a constant, add it to some other row, and that replaces that row there. Okay, that's a little sloppy, sorry. I'll show you another example. The example I have next is a little, I think it's a little ugly, so I'm going to choose a different one. So let's try to solve 3x plus y equals 1 and -x plus 2y equals 9. There is a way, obviously, if you use 4.1 methods to use substitution or elimination, but the whole goal is to get comfortable with these matrices. So my augmented matrix, make sure it's x plus your y term and both of your equations looks good. 3, 1, and a 1 would be over here, a -1, 2, and a 9. Okay, we know the goal. 1, 0, 0, 1. I'll get a number here and a number here. And we know what we can do from our rules. Okay, so usually you go for trying to get a 1 here. You could multiply the second row by 2, for example, because if you did that and add it, you would get a 1 there. Or some people would say, hey, I'm allowed to interchange rows. So your first move, one option. If you recognize how easy it would be for that to become a 1, one option is you can just interchange rows. That is one of your rules. So you could actually just switch the positions. And then you can just multiply row 1 by a -1, and that replaces row 1 to get your 1 in the corner, so that would become a 1, -2, and a -9. Now you didn't have to take this first starting place. You could have multiplied row 2 by a 2 and added it to row 1, and that would have created a 1 here. There's so many different routes you could go to come to the answer. Okay, so that's a 1. That's actually our 1. I like this route we went on, but I need zeros in the other spots. Okay, generally you go for the bottom left 0. You don't have to, but that's kind of the easiest route if you follow the advice. Okay, how can I get a 0 here? Well, one option, out of many, is to multiply the first row by -3 and add it to that. So -3 times row 1 being added to row 2 is going to replace row 2. Remember, the one you add to is where it gets replaced. So I'm not replacing anything in the first, but I'm replacing row 2. So I multiply the first row by -3. So 1 times -3 is -3. Being added to that element 3 makes me 0. -2 times negative 3 is positive 6. 6 added to 1 is 7. Negative 9 times negative 3 is positive 27. Added to 1 is 28. Okay, so in doing that, we created a 0, but now we don't have a 1 here anymore. So let's get that back to a 1. We're going to have that. So really easy fix, 1/7 times row 2 can replace row 2. So I'm just basically dividing all the elements by 7 or multiplying by 1/7. 0 times 1/7 is 0. 7 times 1/7 is 1. That's why I did that. 28 times 1/7 is 4. We're almost done. We just need a 0 here. In order to get the 0 there, we want to think about, can I multiply row 2, for example, by a number, so that when I add it to row 1, that becomes 0? Yeah, very easily. If I multiply row 2 by 2, so row 2 times, what am I doing? Multiplying by 2, and I'm adding it to row 1. Remember, the one you add to is where it gets replaced. So I'm adding to row 1, so it replaces in row 1. So I'm not replacing anything in the second row, but I'm multiplying the second row by 2 and adding it to the first. 0 times 2 is 0, plus 1 is 1. 0 plus 1. 2 times 1 is 2. 2 plus the negative 2 is 0. And then 4 times 2 is 8. Negative 9 plus 8 is negative 1. And I am done. X equals negative 1 and Y equals 4.